Hello everyone, my name is Fernando Pereira and today we continue our discussion on tensor compilers. Now I will tell you about Droplet Search, which is an algorithm that we have deployed onto Apache TVM. TVM is an open source machine learning compilation framework that optimizes deep learning models and compiles them to run efficiently across diverse hardware, from data center GPUs and CPUs to mobile phones and edge devices. Something interesting about TVM is that it uses an abstract representation of kernels that focuses on what the kernel does and not on how the kernel does it. This abstract view is called Tensor IR. Tensor IR is a domain-specific language embedded in Python. We can program it directly if we are system developers, for instance. However, more often than not, we use Tensor IR as an intermediate representation. The TVM front-end uses it as a target to lower models written in TensorFlow or NextPyTorch and such. Tensor IR is very abstract. It does not really talk about many aspects of an efficient kernel implementation, such as tiling sizes, vector widths, thread mappings, memory placement, and such. Finding these parameters is the job of the autotuner. So the autotuner takes a kernel representation in Tensor IR and produces a concrete version of it. There are many optimizations that can be applied onto these loops when producing the schedule. For instance, the optimizer might switch the order of loops. This is called loop interchange. Or it can do tiling, which is very effective to improve cache locality. Essentially, tiling is partitioning a loop into multiple subloops that will keep data closer in the cache. These optimizations can all be combined, for many of them can be applied independently. For instance, it's common to apply interchange and tiling to get better cache locality. Some optimizations have parameters, like the size of the tiling window, for instance, or the number of threads when you are doing thread blocking on a GPU. The universe of possible valid parameters for an optimization forms what we call the search space of that optimization. As an example, here we are showing two of these spaces. In this case, the x and y-axis are the dimensions of the tiling window, and the z-axis is the performance of the kernel if we run it with that parameterization. Well, if we have this search space, an obvious question is how we can find the best configuration of parameters. That would give us the minimal point in the performance curve. Compilers usually solve this problem doing something called autotuning. That's basically a feedback system. We run the kernel, profile it for performance, and then use the observation to look for another kernel. TVM has lots of different ways to do autotuning. The simplest approach is just to sample random kernel configurations in hopes of finding the optimal one. Or else we could vary the parameters on a grid, which is more systematic than random search and avoid sampling the same kernel twice. Or we could try some more advanced techniques. TVM, for instance, uses a genetic algorithm to combine previous observations into new kernels that are likely to be efficient. What Droplet Search does is to use a hill climbing approach to try to approximate the optimal kernel configuration. In this sense, we can think about Droplet Search as a post-optimization phase. First, we find a search space, that is, a configuration that gives us a kernel. Then we use Droplet Search to adjust the parameters of that configuration. Nowadays, Droplet Search is part of the meta-schedule infrastructure, which is part of Apache TVM. So the meta-schedule uses different algorithms to obtain different kernel configurations. Imagine that each configuration represents a different interchange of loops, for instance. It samples these configurations a number of times using, for instance, an evolutionary algorithm, or XGBoost, which is a machine learning technique. Then it chooses the best configuration that it found in this initial exploration phase. And finally, it uses Droplet Search to exploit this configuration via the coordinate descent algorithm that is the essence of the approach. This algorithm was invented during Michael's PhD, who had a scholarship donated by Cadence, and now the algorithm is used in open source projects, such as TVM compiler, for instance. As a result of this work, sponsored by the industry, Michael published different papers explaining how Droplet Search was designed and implemented. And the algorithm itself is very effective. Just to give you an idea, running 300 samples and exploiting the best one with Droplet Search yields a faster implementation of a convolutional neural network than exploring 10,000 samples with TVM's meta schedule. And that's much faster, like 6% faster more or less. And since 2023, Droplet Search is part of Apache TVM. And that's our story with Apache TVM. So before I move on, let me ask, are there questions? If there are questions, please feel free to send me an email.